Welcome back. I have written one question on the board. Now, you know that we have already studied AP. It was in your previous standard, but we did some questions on AP. You can refer the videos which are posted earlier. And then GP is introduced in proper sense. That is, sum of GP is seen and also so called as nth term of GP. Now here the question is saying like this. If S represents sum of n terms of GP, P represents product of n terms of a GP, and R represents sum of reciprocals of GP. You know that if any sequence is in GP, any progression is in GP, that means the ratio of any term to its previous term will be always constant. Okay? So term 1, term 2, term 3, term 4 if you see, then ratio of term 2 to term 1, ratio of term 3 to term 2, ratio of term 4 to term 3, ratio of Tn is to Tn minus 1. This ratio if you see, it will be always constant. And we call that common ratio as say called as R. So here what I will do here, let the terms in an AP B, let me take that sequence to be as, let the first term as gradual, let it be A, and the common ratio is multiplied always. So the second term becomes AR, the third term becomes AR square, the fourth term becomes AR cube, AR raised to 4, and so on. The last term which you know by formula is AR raised to n minus 1. That is any general term, rather to say last term, any general term is AR raised to n minus 1. So let us find one category, that is first S. S stands for sum of n terms of an GP. Now depending on R, that is R is less than 1 or more than 1, you have two formulas. But here you can take any formula which you want, that is A into R raised to n minus 1 upon R minus 1, or it is A into 1 minus R raised to n upon 1 minus R. This is your sum of n terms of GP. Now you see here R stands for what? Sum of reciprocals. Sum of reciprocals, okay? So your R will be nothing but reciprocal of 1 by, that is A, which is 1 by A, reciprocal of AR as 1 by AR, and it is sum, that means plus 1 by AR square plus 1 by AR cube and so on, plus 1 by AR raised to n minus 1. Okay, that is your R. Now if I see here, what I find is 1 by A is common everywhere. Here you get 1, here you get 1 by R, here you get 1 by R square, here you get 1 by R cube, and so on up to 1 by R raised to n minus 1. Right? Now if you see only this part over here, that is 1 plus 1 by R plus 1 by R square plus and so on 1 by R raised to n minus 1. Let it be so called as S dash. Okay, so you can see here, okay, this is 1 by R. For testing purpose, I am taking ratio of third term to ratio of second term. It is very clear that shayad it is not AP, so I will check whether it is GP or not. So I get this as 1 by R square upon 1 by R, which is 1 by R square, divided by 1 by R, means multiplied by R by 1, which is 1 by R. I will check it at one more place, that is term 4 is to term 3. So I get here 1 by R cube is to 1 by R square, which is 1 by R cube into R square by 1, which is again 1 by R, and let this be your common ratio, which is your R. Okay, so ratio is common, that means it is an GP. So I say it's GP with first term to be as what? 1, and the common ratio as 1 by r. Okay, so addition of it, that is S dash, by formula, by general formula, this one you take or this one you take, that is A, that is 1, A is 1 minus r raised to n. So this r raised to n upon 1 minus r. On substituting the values, what you get? 1 minus 1 by r raised to n upon 1 minus 1 by r, because 1 raised to n will become 1 only. So when you make the denominator same, you get r raised to n minus 1 upon r raised to n whole divided by r minus 1 by r. So S dash becomes your, S dash will be r raised to n minus 1 upon r raised to n into, this will be divided, na? So r comes here and this is r minus 1. Okay. So in short, you get this as S dash is equal to r into r raised to n minus 1 upon r raised to n, which you can solve further, but right now let it be as it is. This is your S dash, means only this value. So your r now here, actually I have taken r here, already mentioned, so we will write this as r1. Okay, this is your r1, that will be more better, otherwise we get confusion. So here you get r, that for this reciprocal, sum of reciprocal will become 1 by a into, right, 1 by a into S dash, 1 by a into S dash. So that is nothing but r into r raised to n minus 1 upon a r raised to n into r minus 1, right? This is your r. Okay, this I got r, I have already got S, now I need to get p. So now p is equal to product, it is telling, na? So product of all the terms in an GP, that is a multiplied by ar multiplied by ar square multiplied by ar cube multiplied by and so on till ar raised to n minus 1. Agreed? So what I get this as a into a into a into a, n number of times. So a you will multiply a into a into a into a. So by so called this index rule, it will become a raised to 1 plus 1 plus 1 plus 1 up to n times. So it will become a raised to n. You calculate and see, but anyway you know the common sense. A into a is a square, a into a into a is a cube, a into a raised to 4 it will become, so it will become a raised to n. And here you get what? Multiplication of r into r square into r cube into r raised to 4 dot 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 such a way to r raised to n minus 1. Okay. Now if you see here, the base is same. The base is same. So you can add this 1 plus 2 plus 3 plus 4 plus and so on as n minus 1. Okay. This is what you get. That is total addition is n minus 1. So your nth term becomes here n minus 1. So here if I see, let this be called as, so called as S double dash. Okay. So S double dash is nothing but 1 plus 2 plus 3 plus 4 plus up to n minus 1. Okay. So here your nth term is your n minus 1, and if you see here, it is an AP normally. So it is an AP, it's an AP with A is equal to 1 and common difference also is 1, right? A is also 1 and common difference also is 1. So sum of n terms of an AP by formula, that is S double dash, will be n by 2. So this is your n minus 1 by 2, because nth term is your n minus 1, n by 2 into 2a plus n minus 1d. So your nth term is already n minus 1 into d, which is 1. So here it turns out to be n minus 1 by 2. This is your 2, right? Plus n minus 2. So here you get this as n into n minus 1, 2 cancels, upon 2, which is your this sum of n terms of an AP. Now your P will be nothing but so called as this multiplications of these two, that is I don't have space over here, but I will write it somewhere here. That is, so now my P over here becomes, this P becomes so called as, it is a raised to n into s double dash, that is n into n minus 1 by 2. Okay, now you can see here it is square of P, so I will do that also over here and keep it ready. So here when I get so called as P square, so P square will be obviously a raised to 2n, that is whole square, na? Into so called as n into n minus 1 by 2 the whole square. Now I just have to establish the relationship between them. Now coming to s upon r. So s is your, I have taken this one I think so, a into 1 minus r raised to n upon 1 minus r divided by r. R is your this one, r into r raised to n minus 1 upon a r raised to n into r minus 1. So which turns out to be a into 1 minus r raised to n upon 1 minus r into a r raised to n into r minus 1 upon r into r raised to n minus 1. Okay, so obviously this has the same value with negative sign, this has the same value which gets cancelled with this negative sign. So here I get, what I remain here is this a into a becomes a square, r raised to this by index rule will become r raised to n minus 1. A raised to m upon a raised to n is equal to a raised to m minus n. So I have now s by r, and I think so it is raised to n. So it is a square r raised to n minus 1 the power raised to n, which will become a raised to 2n into r raised to n into n minus 1. This is your what I got. Now this and the result of so called as p square. P square on solving I get here a raised to 2n into, that is n into n minus 1 upon 2. Yeah, this also is whole square. Okay, this is your whole square. So now let us talk its role with this r raised to power. So that is to be solved. What we will get here is, so what you get here, this value is only of s double dash, na? S double dash value is there, that means only this value. So this base r is to be written yet. So that s double dash I will get, and here this is p. Okay, so p is what, a raised to n, and here is your base r which is not written here, huh? So that should be here r raised to. Okay, so this is r raised to actually, and here also I will write it down so that we will come to know here. Like this I will write, that is a raised to n and r raised to, okay, r raised to this power, okay, and it is whole square. That means this is p square, na? So what I will do here is I will close the bracket from here to here, that is till here. Let this be n into n minus 1, that is n into n minus 1 by 2 let me close it here and make it whole square. Okay, so that particular thing what I get here will be, first I will go through that particular part what I get, and then I will move further. So p square what I get here will be a raised to 2n. Okay, it will be a raised to 2n, and r raised to n into n minus 1 by 2 raised to 2, that is r raised to n into n minus 1, which absolutely matches. So therefore what we get here is that p square is equal to s by r whole raised to n is verified. The wanted to save the space, but still it is very big, but it is very useful result when you talk about so-called as entrance. Now, so this particular results are very useful. Hardly it is means not very difficult to remember. It is very simple. Only q is not there. Otherwise, you can remember as p q r. After p q r and s is there, right? So p square is equal to q by r raised to n, you say, where q will stand for the sum of reciprocals. Okay, it will be very simple to know. Same type of questions will be moving further in the forthcoming sessions. Till then, goodbye.